everyone, we're going to use the midsegment theorem to answer these questions. So they give us all the congruent sides. So basically, these two sides are congruent, these two sides are congruent, and these two sides are congruent. That means these points all here are midpoints of the line segment that they're on. It also means that this line is parallel to this line. This line is going to be parallel to this line. This line is parallel to that line. So let's answer some of these questions. Maybe we already did. RS is going to be parallel to line segment JL. ST, where's ST? That's the orange. ST is going to be parallel to KJ. And KL, that's our green, is going to be parallel to RT. Now SL is congruent to KS. And that was actually given. But it's also congruent to RT. And the reason it is this is the midpoint. So for example, if this whole line was 6, then each of these pieces would be 3. And according to our midsegment theorem, this line is half of the 6, which is 3. So they're all 3's here. So that's why that's true. And I'm going to erase the 3 out because that was just an example. And we can do the same thing with all the other lines. So we can say that JR, where's JR? This line segment is congruent to RK. But it's also congruent to this line TS or ST, however you want to write it. Because again, this line here is double this line. So if this was 3 and this was 3, the whole thing being 6, then this is half of 6, which is 3. And then we can do the same with the others. JT, and maybe I should just erase all this now. JT is congruent by TL, which is also going to be congruent to RS. And again, that's because if this is 3 and this is 3 and this is 3, this whole thing is 6. So that follows our midpoint or mid-segment theorem. These two lines are parallel. And that's it. Thank you. Have a nice day. Bye-bye.